Go ahead. Okay, hello everyone. Welcome to a design review for version 14.2 about discrete computation, strangely starting with GPUs. All right. So
To the goal, if you go to that guide page, I think that sort of describes the overall picture of it. Source in the source. And if you click on that, no, the other one. Oh, it's so hard to use.
why are these icons failing? Somebody needs to check into that. Roger, since you're not doing project managers, it gets to be you.
Sure. Because your scheduling staff failed to add one?
Apparently so.
Mm.
All right, I'll do it. I'll do it right now. I'll follow up.
Is it actually working on Apple GPUs? Because when I tried late last week, it still wasn't.
I don't know.
Charles?
Can somebody answer that, please? Charles, are you here?
I am here.
Okay, so what's the answer to that question?
The point of this meeting is a design. So we are discussing the design. We are not discussing the detail for implementation.
Well, is it working though?
It's right now, we are completing the implementation for NVIDIA, right?
Okay, but you're going to do the Apple one, right?
Yeah, so let's talk about that.
Yeah,
so there is an Apple. So there's several backends, okay? So the point here is to be able to provide this
is going to be a long design discussion because I don't think this is even close to right.
Okay. I'm sure
I
you
don't
have
think this is even close to right.
Okay, great. Then let's have a discussion. So the
Okay,
point is
we're going to go to
this
some of the other parts here because we need to actually get through a lot of this other stuff.
Uh-huh.
We're going to have to come back to this. But go ahead, Roger.
Yeah. The point is to have so one of the big problems when you use accelerators like a GPU is the memory transfer. That's a high cost. So if you create something that lives in that memory space, you can amortize that cost over many computations. Now we can recognize that is such an GPU, and it will call on an operation that's available for that GPU, which is typically or can be significantly faster than on a CPU. Now, this can enlarge in many ways. There are several possible backends. The most developed one is by NVIDIA and the CUDA framework, but there are similar things catching up for the other ones, including sort of the MLX framework for Apple integrated GPUs, ROCm for AMD GPUs, and one API for Intel GPUs. You can also expand in the number of operations that have GPU array implementations and methods.
Can I run this at all?
Not on a Mac.
I mean,
not on your machine
right
now.
If somebody had told us that we need to use, I can run this on a machine with a GPU. Is that going to be useful?
You could, yeah.
Right, yes. So if you have
has somebody installed a prototype build there? Anybody know?
No, I don't know.
Probably not. Which machine do you have in mind?
I mean, you could
my machine's an AMD Threadripper machine, which I have has a.
Does it have an NVIDIA card?
Yeah.
Okay.
Yeah. I mean, I doubt anybody's installed this there, so I don't think we can do it. So let's prep that.
You could
for
use
another meeting.
r2.wolfram.com.
Then I have to set up the remote kernel
Yes.
there, so on. So let's not.
Well, the idea of this meeting, at least for me, was essentially we are going to focus on the design. If we need to show off, I can show some of the functionality that are already working, right? But we don't yet have the implementation on Apple, so you won't work on your machine right now.
No, I understand. But if somebody had actually prepped this meeting properly, we would have known that this version.
Why is it important for you to run it?
Because I'd like to see it actually run. I'd like to understand it by seeing it run.
Charles can share that and see it run.
Let's not do it that way.
And I haven't informed Roger Dooley,
and you
because
have no examples
we did
here.
What?
You have no examples here.
Open scope.
No, we don't yet have example there. I have example in my notebook. I can show how it works. So that was the idea, right?
I think we should go on to another section here and come back to this. Okay. I mean, I think that if what you've managed to do is to get these operations to work directly with a GPU array, taking a GPU array in and putting a GPU array out, is that what you've done?
Yeah.
How does mean work when it takes a GPU array in? What does it give out?
Well, if it's just a vector, it's a scalar. It comes out, obviously.
Okay, so it's an ordinary scalar, not some kind of GPU scalar.
Yeah,
correct.
So it's a value.
Yeah, and I don't think we actually have mean implemented. Maybe we do.
It's implemented Itai. Hold on, right? I know what we implemented, so hold on. Okay.
This is all the ones on this page are actually done?
No.
No, the linear algebra is not done. The Fourier, so most of the one which are in this page, we can actually implement them. And if we go with the design, it will be done by the time we release. Okay. So linear algebra is not yet done. I mean, the array one.
Pieces of it are done, but not certainly not everything. And it's not clear that I'll be able to do all of the linear algebra pieces for 14.2. But I certainly have dot, transpose, linear solve. I've almost finished with SVD. So,
but the basic setup is similar to a numeric array. Is that correct? You put a numeric array in, you get a numeric array out, similarly with a GPU array, correct?
Yeah. Correct. That's the idea. Right.
But it also has
pretty much on the CPU, GPU array on the GPU.
And what about the compiler?
Yes, it works with compile, all the functionality.
So is that a type? Is it a GPU type or something in the compiler or what?
Yes, it's a type. Pretty much a container which contain CUDA, vector, or the different backend.
But so what's that going to work in the compiler where we have a target device arrow all or whatever? How is that going to work? Is it going to with GPU arrays? Do you understand my question?
Right. But it have to be targeted to every specific device, right?
No, I know that. The point is that with the compiler, we have a mechanism to compile something in LLVM that can be a single object can be delivered for all different devices. So what I'm asking is, what is the GPU analog of that?
Right. So if it's the case that you have that target framework, that will also work. I mean, that's why we want to implement it for every platform, right?
No, I understand that, but you need to work with Tom. Okay.
Right. So we are. First of all, we are. Second of all, if maybe I can give you an answer that will be which will have better impedance matching. So we have a GPU array compiler type, and we're hooking this into all the system functions.
By the way, here's another thing which we should do. We should put this compiler types list up here. Somebody can follow up on that, please.
I'll make a note of that.
Thank you.
Right. And so you can write sort of normal code using, dot and sign and SVD of your GPU array, and you can compile that, and that'll sort of be, then generic code, and it will call our we'll set up precompiled code for, dot, one for CUDA, one for Apple, etc. And then, so you can call function compile on code involving dot and GPU array, and then that code will call the optimized code that's already in the layout when it gets to that function.
I see.
But,
and that will happen transparently.
Hold on. So I was reserving that answer because let's not be naive, right? I mean, every hardware, we need a custom implementation. So there is no guarantee that the implementation of min or, whatever linear operation we'll have on CUDA will have it directly on Apple. So that's why I was reserved on that answer, right? So generically, So generically, right, we try to implement, support. We want to support every function for every platform when we can. But there will be cases where that will not be possible. If you have the implementation uniformly, like you say, target all will just automatically work. I mean, it's a framework the compiler have. We don't pretty much have to do anything.
I don't think that it will just work. I really don't think it will just work, because it makes use of this intermediate level of LLVM code that can be separately targeted for each particular hardware device.
It's exactly what we use. I mean, we are just writing the whole code on top of the GP on the compiler.
Okay, fine. I think you need to talk to Tom about it.
We are
and
talking
I understand
to
your
Tom.
point. I understand your point, but I mean, I don't know what's involved in having it change types depending on, presumably, I don't know what's involved. Maybe it's saying sometimes it can use a GPU type, sometimes it cannot, depending on what the underlying hardware is. Is that correct?
We will make sure it works, but yes, it's just a type. Right? It's like any other type you define in the compiler. The key difference at the end is, the library or driver at what level we are calling, right? So it's essentially that. It's nothing really different than, anything else we write.
All right, okay, fine. The bottom line is it's important that we set it up so that you can make a function that will just work on any machine. It will use the GPU if it can, it won't if it can't.
Exactly. So that is how it's set up. There is another mode which is useful for developers, which we can activate maybe with a system option, which will make it fail if there is no such operation. I think that is useful in a debug situation. I don't think it's useful for consumers.
Right.
Right.
I mean, I think perhaps what we do is we make one of those blue boxes that comes up or something, or generates a message. I think you should have three options: generate a message, fail, or just silently, go to CPU. Am I making sense?
Yep. It's actually what we're implementing.
Okay. So here, all right, but what options do you have and how this is laid out in GPU memory?
But
why would you want to know that?
Exactly.
I don't know. Maybe it doesn't matter.
No,
it doesn't matter. It's the same like
it's important to abstract that too.
Okay, that's fine.
Right.
Does
but
it work well with sparse arrays?
Yeah. So yes.
Not yet.
But the idea is that it will.
Yeah, yes, but I mean, we have the pieces. I mean, it's just really rough right now. So, but we have the pieces to make it work. That's just further down the line than cleaning up dense arrays first.
Yeah, fair enough. So just so I understand, image processing, for example.
Yeah. So in the future, okay. Yeah. So one of the things that we can do for objects that are sort of more sophisticated, like image graph, is that in the second round of this, we can silently replace the data representation with GPU arrays, and they can go GPU accelerated.
Okay.
That's the idea.
And so how many internally implemented functions will use GPU arrays?
Right now, you see them on your guide page here, right?
And right now, it will just activate if the input is a GPU array. Right, so we are not going by default in this round. Use the GPU.
No, I understand, but in our internal implementation.
But that's second round, Stephen. Okay.
Okay, I understand. But I mean, this
is a base. This is a foundation on top of which we can go pretty damn far.
Next question: discovery interface for knowing whether you have a GPU and so on. What is it?
Okay, so we're looking into that too. We need to improve the system information. We want effectively like a tab or expanded
I agree.
support for that. And
who are you working with on that?
Well,
I mean, once we actually have something to show in system information, obviously we will work with Lou on that. But we're working on the lower level bits. And
another thing that relates to that, to what you're saying there, is that we think, I mean, first of all, the Wolfram benchmark was, needed an update.
Yep.
And this is a really good reason to provide that update. Then we hope to not only sort of update for CPUs, but provide something that tries to leverage GPUs. And now you can compare machines based not only on the CPU capabilities, but together with our GPU capabilities.
Right. I mean, I would suggest in addition to system information, I think, really this is a complicated bet. I didn't believe that GPUs would still be with us. I thought it would all have been just, fallen back into CPU land.
And I expected by now that they'd figured the memory copy problem.
Yeah. Right. So the question is this a permanent function or not? Or do we expect that this is a few-year function that then becomes legacy?
I think that it's pretty permanent. It might be part of a more general array object when we go to do modernizing.
No, I understand that, but I mean, because even it's like I
right.
can tell you about
I think
color maps for printers, or for displays, and those are things of ancient history.
I think there will be. I think this is a more or less permanent object, just because they may get new names, like they might be called TPUs instead of GPUs, but there will still be a need. There will still be objects that are have specialized algorithms and will want to be able to represent memory that's not on the CPU.
That's what people said over and over again back in the 90s for all kinds of special purpose processors, but it's okay. It doesn't really matter.
Well, the thing is that I think we need to. I don't think we can sort of not use that resource.
No, I agree completely. Is this still the old one, or is this nice and new?
This is the new one.
Yeah.
Can you get a graphic design pass on this? These fonts are terrible. Those fonts are terrible.
Yes.
Yep. Just get graphic design pass, please.
For sure. But everything is sort of modernized otherwise in terms of how it's actually built up with templates and whatnot. And
where's my machine in this? There's my machine. But it should be much clearer that where's the machine, right?
Yes,
that's just a graphic design point. Yeah, it should have an arrow or something here. I mean, there's a bunch of, if you can get this,
the other thing that you will see here, and I don't know where that is, Charles.
Hold on. Let's get a round of design, and then let's bring this to a design meeting, please. Graphic design meeting.
Sure.
Okay.
The other thing that's there, but I don't know. Oh, there it is at the top. So you can submit your machine. Okay. That was not the case in the past.
Here. But that's not the right icon for that.
Yes, those are temporary icon. We have to work with the design to get all that in place.
Now, is there these are new tests, I take it? Is there a way to get sort of the original suite, or is this just like you've prettied up the existing tests?
I think they're just scaled up version of the existing tests.
Right. So what we are doing,
can I make a suggestion here? First of all, you probably should have some more OS information here. And second of all, you should make it optional to include the machine name, because people may not want that included. Do you understand what I'm saying?
Sure.
And I think the fact that, where does it get the 24 cores from? Because that's a separate issue from the machine name. Isn't that dollars? What is that called? That gives you the number of cores.
Dollar process count.
Okay, so then we should have that separately as a separate line here.
Right. So this interface, this window you are looking at there, is just to kind of briefly tell you this is the information we are going to push.
No, I understand. I'm just giving you comments, which hopefully we, it's again why we need a project manager here. But in any case, so you should not combine these together. You should make sending the machine name optional. I'm not even sure you should send the machine name. I kind of think you shouldn't. You can have an optional thing there to send a machine name, but I think in general you shouldn't send it. Does that make sense?
Yep.
Okay. Benchmark.
I'm also here, Stephen. I'm taking notes on this. I'll pass along.
Thank you.
Is there an option to get the original test so you can sort of compare across versions?
There should be.
It's relative. What does it mean by compare across version? Right. So
but it's the same test, the same Wolfram language code.
Exactly.
You should be able to run it.
Yes.
Go ahead.
So it's there. So you at the bottom of the page, you have the Wolfram Mark source. So the earlier one, you can call it the Wolfram Mark 1.0, which have earlier tests, maybe shorter and such. Starting version 14.2, we have a new benchmark, Wolfram Mark 2.0, right? And you can access it. You can decide to run it on your old machine or not. It's up to you to make that comparison.
Right, but what if you want to run version 1.0 in 14.2?
Whatever, if you want to use version 1, we are not going to bother about it, right? So that's my point.
Well, I don't understand. I just want to know, how do I generate a report that is like the report that I got in previous versions with the same tests as in previous versions? That's the question. How do I get the Wolfram Mark 1.0 on version 14.2?
Why do you want legacy tests?
I want to have them because people are going to want them.
But then you run it, you copy the test and then you run it.
Where do I get the tests?
But you run the old version.
No. In the new version, I want to run the old tests.
Okay, so you want us to add a new function to generate the old test.
I want you to be able to make this benchmark report have, put quotes 1.0 or something, or just 1 in there to run the previous version of the tests. That's all. And then it should say what version it's run here, which you do. Benchmark name there, right? I mean, this desperately needs graphic design, but it's a good now. I mean, some of these are similar to previous tests, right?
They are this previous tests, just scaled up. So that's another thing. We're going to go through a round of soliciting more sort of modern kinds of tests.
Okay. Good. And maybe we could ask the community folk for that too.
Right.
What does this generate?
That looks to me like a printer button.
Oh, that's printer button. Right.
Okay, so this thing here wasn't. It was a hijacked icon, but the other one wasn't. Okay. What's benchmark? Oh, that's the same function. So I don't think this is the right way to do this. I think these things should be WFRs. Am I making sense? That's the modern way to do this.
Okay.
And I mean.
So we should remove it from the layout?
It can still be in the layout. So. We can build the interface, yes. It can still be in the layout.
What's the difference between benchmark and benchmark report?
Benchmark does just gives you the raw numbers, sort of benchmark as rules, and benchmark report.
Benchmark run the base benchmark, return you a data set. And benchmark report generate the notebook.
Well, I think you should repackage this a bit. Those two, combine them and make the whole thing a WFR, and benchmark submit a separate WFR.
I mean, these are documented package functions, right?
What do you mean they are? Where are they documented?
In the doc center, if you double click on it and hit F1 or Shift Command F, then you will go to the ref page for these functions.
It's a package, so we can do all that change. So that's not the point to focus on that.
Yeah, I think this is not the right way to do it anymore. I mean, it was at one time, but it really isn't anymore.
We can easily move it to the WFR. That's not a problem.
I think that's the right place. I mean, Roger, do you have any counterpoint to that?
I kind of think it's a cool thing to have in the product, and people love.
This is not in the product. This is a package.
But it's in the product. It's in the layout. You don't need any network connectivity to run this.
I think that, I used to, it's so funny, but first thing people would do when they got a new machine on MATLAB was run the benchmark. And then I noticed people did the same with us.
Yeah.
Well, and fair enough. Talk about it on community and whatnot.
Fine. If we think it's that important, then we should make it a system function. We should not make it something where you have to load a package. That's not how we're doing things these days.
Let's make it a system function. I think it's the right thing to do.
All right. So I don't think it's obviously bad.
I don't think so either. I mean, we do get frequent questions from tech support and sales and so on, where they like recommendation for, a machine for, so-and-so workload.
I agree. But so let's do then a little bit of design, which we're not going to do in this meeting, to make this a system function. And hopefully it's a single system function, not a triple of functions and so on. This benchmark submit can
we could
easily
have a function that has a sort of argument that says what kind of output you want.
Sure. But I think this is very similar to running tests, right? We have our tests and we have a whole mechanism for running tests, right? You know what I'm talking about, right?
Yes.
And, whatever mechanism this has, this is the same type of thing. Maybe you can even make your own benchmarks by putting them into a testing. I don't see why you wouldn't be able to make your own benchmarks here.
Actually, Charles developed a framework where it's easy to put together a new benchmark now.
Okay.
Right. I understand all the extension and we love extensions, right? But the point is why, if you allow me, we can generalize this and spend most of the time generalizing something. The idea of the benchmark, at least from my point of view, is a set of tests with, we curated, people run, right? There is a mechanism, which is the submit, where people can decide, hey, I will like the following test.
I understand, but I'm saying as a system function, what this is going to look like is some kind of thing where you say benchmark, I would call it system benchmark, because I don't know I think that's a useful thing to do. Call it system benchmark. And then that default thing would generate some kind of display on the page. And then, system benchmark of notebook or something. But I think we really need to reserve, I kind of think that we should do something like this. Because I think the first argument should be a specification of which of many possible future benchmarks this actually is. Am I making sense?
Yes, because the type of Wolfram versioning. Yeah.
Right. I mean, so for example, I think 1 here should give us the old version and so on, and the default will be whatever the latest version is.
Yep.
Am I making
sense?
That
was the idea. Yes.
And then benchmark submit should be a WFR, even though it can be a button press from one of these things here. Make sense?
Yep.
Okay. Are we ready to move on?
Yep.
Okay. Who are you working with the technology conference attendees on getting this stuff, making them aware of this?
Well, right now we're first trying to work with the pre-release, with the QA and.
Okay. All right. Okay. But who are you going to? I mean, technology conference is not far away, so who are you going to work with for that?
I haven't thought yet up to that.
Okay. Well, maybe
we thought
Tracy
that the pre-release crowd would be excited over this.
No, I agree. Okay, let's move on. Geometry. Oh boy. So, I mean, if I say geometric model, open, close, nothing happens. How do I find?
Probably put a open, close, a string star.
This kind of browser, okay, I don't know what this even means.
So these are the list of the model available right now.
This seems weak. I don't think this is the right way to do it. Look, we've talked about this before. The thing with system model, system model examples function, which I have really not liked. We've talked about the fact that we need a framework for making browsers like this. We tried to do this with like audio searching, et cetera, et cetera, et cetera. I think they're all a mess. And I think we should have a uniform, you've done that with 3D models as well, right? There's a 3D model search thing, which I don't understand how this relates to. What is that even called? What is the
We never shipped it.
We never ship it.
Okay. Well, what was it? How was it going to work?
The idea was to have a gallery picker, and we never ship it because you stop it from us from that, because you said they were building a gallery picker for the cloud, and there will be a version on the desktop too, which never happened.
Okay, why wasn't that pushed? Why wasn't that pushed? What happened? Did it just die?
Well, I never heard back that it was implemented on the
From whom?
desktop. I've never seen an implementation.
I understand, but that's why you need project management, is to make sure things like that don't die. All right, we'll take this to a different meeting, but that's what we need for this. If you want to do something like this, I recommend putting these in the data repository for now. You have a very small number of them, just put them in the data repository. You can absolutely call them from there. You can have something which you can have a geometric models, bolts geometric models or something, or NOP, whatever this is, NOP, SCAD, whatever, in the data repository. Does that make sense?
Yep, can be done that way too.
I mean, we're not committing ourselves to something as general as this with how many models is it here? 27 models. That's hardly the general geometric model solution. So let's put this in the data repository, and let's try to get, just like we have NetModel, for example, which is a fairly serious repository that has, where you can say NetModel of a properly curated name, right? We can do the same thing here. I would recommend, I'm not quite sure why you want these things. Why do you want this? What is this?
Well,
why are you not just giving regions immediately?
Well, the key idea is that those are parameterized region, right? And essentially, those models are coming from mechanical design, for example. So where you have to use unit, you have to have a precise size, right? They're not generic abstract regions. Right?
And so how do I know what the parameters are here?
So if you look at the example below, you can say comma parameters, and I probably didn't put it here, but I think you can. Right. If you generate the model and ask parameter, it will give you the list of parameters.
I mean, what is this? What is that nonsense there?
Oh, so that's just an example where we take a collection of, this is a, IO and other, technical part people, already pre-built. And then you can get the information, for example, the length, the width, the diameter, and then you can adjust those parameters.
This is a total mess. I mean, this is, okay, so you're doing this, you're mapping it over these things, all 5 of them, or all 4 of them here, right? You have a very small number of models here, right?
Yes.
So what you're saying is the model, the parameters for that very small number of models. So if I take this blower, for example, I should be able to say, I don't know why it's brackets like that. I would assume it was geometric model to fit in with everything else. It should be geometric model of this comma parameters, right?
That should also work, right?
But it doesn't.
Maybe it doesn't, but it should work.
Yeah, it should work. And it should work to not even have the geometric model head here, because this thing should be a geometric model, right? That's what we've done for other things.
Yeah, so that's why right now, if you just take that thing and then you apply geometric model on it, that's what works. Right? So there.
Oh, that appears to work. I see. Okay. So I don't understand why we're not using our unit system here.
We can adjust that. I mean, all this is, is just first we go to the review, we adopt
okay, so you know what? You know what? Here's what you do. You just put this in the data repository for now. This is a deeply uncooked thing, right? It's got all kinds of weird stuff here, right? It's a fine thing for the data repository. It's not going to work for anything else. Fair?
Okay.
But we also should get this ability to, okay, if you want a repository of these things, which would be lovely, then we need to build that. I mean, are you imagining that we would have a repository of our own of this, or we're merely going to a bunch of libraries?
The idea is that, people will build, or ourselves will actually convert existing library out there.
Okay, so like the Thingiverse, for example, is full of things like this. Is
that's
it relevant
more like
or
geometric?
Not?
That's like more like regional web search. I mean, that's
this is more, oriented to
but do we have region web search now or not?
No, that's what didn't ship for the picker problem.
Okay. So I think that will be a good thing to figure out how we do it with pickers. But I mean, is this really for pickers, or is this? I know that is
I think this is a little bit different. Okay,
4010.
Thingiverse doesn't usually have any parameters. They're just a huge collection of.
No, I know it sometimes does have parameters, but usually doesn't. They never really managed to make that take off, I think.
Okay, but more if you think of, kind of like system model components, like a resistor has a parameter, namely,
I am well aware. Yeah,
the resistance.
So we need a consistent approach to this design, right? And this isn't it. And putting 27 things into a function with a big name like geometric model doesn't make sense. So for this version, what we need to do is just put this in the data repository. And then later on, what we need to do is figure out if we're going to have canonical names for some of these components, and we're going to curate the things, and we're going to actually have some systematic way to, to set this up where, which should be merged with what it is for system modeling. Does that make sense, Roger?
Probably not, but we can talk about it.
Why not?
Because the Modelica framework is a giant framework and they really fit together. This is not it. It's like 6,000 objects in just that we ship with it. And probably many times
so this is just a data repository item. So let's move on. What am I seeing here?
So in this case, we extended CIG region to support Bezier curve, field curve.
That's nice.
Bezier curve.
Does that mean we can take glyphs and do interesting things to them?
Yeah, we should be.
How do we get the Bezier curves from the glyph?
Right now, if you discretize your text, you should get that.
With region discretize?
We discretize the equation. I mean, there's a front-end call. I don't think we have a general function which exposes it. Now, you probably need to wrap text around it. And discretize graphic and of text.
Okay, that's nice. It'd be nice if that was a little bit more, if it flowed a bit more smoothly. But that now doesn't show. I mean, that probably has a Bezier curve there, but I don't think that is illustrating it with a Bezier curve.
Right, but if you discretize it, it's gone, right? So
okay. So what is the analogous thing to get the true Bezier curve glyph out of that text?
We don't have a function which return it. And maybe in the next version, when we are right now working on spline, maybe we'll have a function which can actually generate that directly, the spline.
Now, one thing that happens, like when you import a PDF, isn't there a way of getting these region things from the PDF?
Yeah, that's pretty much the same backend we use to get this glyph.
Okay, but so whatever it is that is the mechanism for the PDF, we could, we can use that as a design pattern perhaps for this. Okay, but anyway, this CSG region thing, what else should I be looking at here? I mean, it's lovely, but is there anything particularly? I mean, you're saying the CSG operations now work on Bezier curves.
Yeah, the other thing is the annotation support. For when you build it up as a composite thing, you can have annotations like styles and other things.
So, in the earlier version, we show that you can style the CSG region. So annotation, I mean, it was one specific type of annotation we expose with styling. So now we kind of expose the whole full backend of annotation. So
what does this mean? Is that what does that 2 mean?
So it's a position 2. So the CSG region, if you think about it, is exactly like a tree, right? So that's exactly the spec we use for a tree. So if you take that object and do CIG region 3, if I believe correctly.
So for a graph, the annotation is by node name.
An edge
Yes.
name.
Yes, an edge name, edge specification.
Yeah.
For a mesh, what does that mean?
Cell.
Cell.
So it's a numbered cell.
Yes.
Yeah, I mean, you have
cell
to go.
Index.
Yeah.
Okay, so in the CSG tree, there's a well-defined tree element specification. Right?
Yes.
And we can get the CSG tree as a tree, right?
Yes.
So like this thing here, how do I get the tree version of that?
CSG region 3, if I remember correctly, the function. So CSG 3.
Okay, lovely. Okay, seems reasonable to me. The annotation. Okay, so it has the same mechanism. How does that relate to the annotation of a tree itself? Trees get annotations in their elements, right? In the tree elements.
Yes. Not at all. Not related.
Why not? Shouldn't it be related?
Could be.
I mean, the CSG region is a tree ultimately.
Yes.
Well, I just think worth looking at. I don't think it's the most important thing in the world, but it seems worth looking at. Okay.
In this case, we extended region. We support now join curve and fill curve more generally.
As a non-discretized region. What did it do before? You said region of joined curve.
Well, it was not a region, so it will fail.
What does it do? It just says I fail?
Yeah, in earlier version, it's all graphic primitive were not regions.
Yeah, it's taken a while to be region queued as a huge computational framework.
No, I know it's difficult. I'm just trying to understand what the interface is. In the previous version, this will just say.
Maybe it says I'm not a region.
Yeah,
that is a terrible message. That's confused me 1,000 times. Well, not 1,000, but certainly 20 times, because I don't know what that means. It means there's not a supported type of region, right?
Yep.
So that's what it should say, not this, because that means it could be incorrectly specified because it has a none instead of a one or something. You see what I'm saying? So are there now graphics primitives that we have which are not yet supported as regions or not?
I'm thinking some of the weird settings for tubes are.
Okay, if anything is not supported, please change this message. Just say what it is that isn't supported as in a region, and I guess you should say use discretized region instead or something. Discretized region instead. Does that make sense?
Yeah, we can try to change that.
I mean, it would have been better if this message hadn't been silly in the first place. I mean, are there other messages like this that say you can't get from here to here from there type thing in the same family of conversions between regions and discretized regions and boundary mesh regions and so on?
No, I mean, in this case, it was just an input, right? So since we couldn't really convert or understand the region, we just return it. So.
That's correct.
I know. How do I fill that region in? How do I put solid inside that region?
Fill curve.
Where?
In the whole thing?
Instead of join curve, right? Fill curve.
Okay. You know, I am wondering whether that undefined thing is actually the right thing for those. Why did it have that extra space up here?
Yeah, I noticed that it's something we're investigating.
Okay, so it's a bug.
Yep.
Okay. No, I recognize there's probably a lot of work going into this. Just so I understand, if I were to take this puppy here, and I would say down here, after generating this creature, I would say area of that creature.
Your work. What?
Nope.
Okay, what's
Not
going
yet.
on?
We needed to implement the last version. We haven't yet finished
Okay,
that.
so listen. You can't have stuff like this work this way. Okay, if it doesn't work, you've got to produce a message, because otherwise, I don't know whether I did something
Yeah,
wrong in specifying area.
yes.
I did something, just make a message that says, whatever it is, CSG region is not currently supported, whatever it is, right? But don't just silently fail like this. These
Yes,
functions are way too, it's too complicated to know how you have the right kind of structure, whether you have the right kind of structure.
Yes, we are still implementing this last case. We are still implementing. It will work.
Okay, but I'm just saying anything that doesn't work, the best thing is if it just works. But anything that doesn't work, you've got to be more transparent about what actually went wrong. Fair?
Yes. And
So
we
can
try
you make
to,
sure to
yes.
go through the different cases and make sure that you've actually covered things like this and never have, I mean, this is just too obscure. There's some cases where we can get away with a message that's obscure like that, but not in this one, because it's just too confusing.
Okay, we will do our best to fix that.
Okay, so here, for example, if I say this, and then I say filled curve here, I don't understand why we need to say discretized boundary region. If I just get that, why am I, so could I not just say region of that?
Yeah.
Yes, the example is just showing that discretization work on it.
Now, why did that give me an exact number?
Because we cannot do the exact computation.
How do I know that? I mean, I don't understand quite why you can't do the exact computation. I mean, if I made this a regular polygon, a pentagon region, for example, then I'm pretty sure that if I say area of that, I get an exact result. So I don't quite understand why
in general,
this is different.
Okay, so in general, the working precision is set to automatic. It attempts to do an exact computation first.
All right.
But
so the part you can't do is the filled curve part. Is that correct?
Yeah.
Correct.
I think if it did deeper analysis, we would be able to do this one, obviously.
Yeah, I understand. It's okay. I just was trying to understand what the story was. And if I were to say
so that's actually we've talked about this before, but it's really an important principle for geometry, that things get really complicated, and most things would hang if we tried.
And it's kind of stupid to do it. Right. So I like this working precision arrow automatic. It makes sense.
Right.
Although if what I did here,
you can insist, right? If you did that and you said working precision automatic, it would, do its darndest.
Well, infinity, right?
Yeah.
Okay, so that's again not acceptable. You've got to produce a message in this case, because I would have no idea. If I made this a filled triangle instead of an unfilled triangle, then I could probably do this, right? You've got to produce a message. Okay, Charles?
Okay.
Does that make sense to you?
Yes.
Right, because I have no idea. Without getting inside your mind, I have no idea why this doesn't work. See what I'm saying? I have no idea whether this isn't an area, it should be a volume, whether it's I just have no idea, or whether working precision is not an option for area. I don't know anything. That's pretty weird too. That's not working precision of 30, is it? That's a bit unfortunate. What happened there? That's for Tracy to look at.
Yep, I made a note of it.
There. Okay, do you see that? That is not right. You should generate a message in this case saying you can't achieve that working precision, just like we do for other numerics functions.
Yeah, but but we have to make a distinction between working precision and accuracy goal or precision goal. Here is not the target is not to reach that.
I see. Okay, all right. So if I say precision goal, I don't have a precision goal. So what is the point? Okay, that doesn't seem to work either, does it?
It should actually generate that we don't support precision goal, but yes, that's the thing.
Well, why is it black? We don't support it there.
Yeah, it's the bug. You have to fix that.
Okay. Okay. Graph theoretic stuff. Well, that's cool. I want to see this. Are you calling it friendly introduction or a friendly introduction? I see. You can't call a friendly introduction a computational approach. That's cool. Is that your first book, Charles?
Yes.
Good stuff. Are we making a printed version too?
Yes. On demand.
Yeah, I like the calculus book. The look of that. I saw the printed version of that. So if I want to learn about quadratic residues, quadratic residuosity, and those kinds of things, do I learn that here?
Yeah, probably on the chapter 5, the fertile equations.
Okay.
We didn't went too deep. It's kind of a friendly introduction.
Yeah, fair enough. That's cool. What's this? I don't understand.
So in this case, this is WFR package where we did this, comparative analysis with other network software out there.
Packlet repository.
Yeah, packlet repository. Thank you. And essentially, we are trying to introduce all the one-liner and trivial function and name function people have out there through that framework.
So this is a precursor to actually trying to do a serious system level design review of these things. Is that correct?
Well, you can at least point to say they're all there.
Yes.
I understand.
Okay. and most of them should not be system level functions, probably.
But will they have pointers from, or they have cross, oh my gosh, what do we call that project?
You mean see alsos or something?
Yes. But we have the
cross-linking?
Cross-linking project, right. Do we have those cross-links, or are they not defined here yet?
I think we haven't defined it. We could try to go after that.
I think should. I mean, just if you link from here to the system functions, then I think there's things that will pick that up. Now, I'm a little bit not thrilled about the fact that those are packlet symbols. I think it'd be better if these were just WFRs rather than having to pull in the whole packlet. But if that's the way the technology works, it's okay for now, I guess. It's just that it's much easier to document things as WFRs. Okay, this is exciting here. I mean, this is useful. No question this is useful. I'm just not completely sure this is the right way to do it. Certainly better than nothing.
Right.
But I think we should have a separate review of this and related things which are kind of,
I think that's fine, Stephen.
Orbiting.
I think it's fine. I mean, this is partly breaking new ground, doing things we haven't done before.
Yeah. So. Well, I think it's useful, but I would, as I say, my preference is for WFRs. Because particularly most of these things like periodic graph queue, I can kind of understand what that is. It's a standalone concept. It's not like these have a lot of interdependencies. It's not like they're making a data structure that's used by other ones. They're really just, I have a graph. What am I doing with it? Here it is. See what I'm saying?
Yep, makes sense. Yep. They're pretty much all of them, most of them independent on.
Yeah, then I would just make them into WFRs. Putting in a large number of WFRs is not a problem. Okay, graph drawing. I'm excited about this because I'm a serious user of a graph draw. Oh, thank goodness. Yes, you are. Oh my gosh, this particular thing. Yes. Why is it called state embedding? I have no idea.
I mean, that was the point of this discussion. The point was, I mean, we propose that we can call it symmetric layer embedding. Or
I think that's what we should call it. Symmetric layered embedding. Sounds right to me.
Okay.
I can't imagine what, I mean, state of what? State of the union? I mean, state of...
No, it was coming from your example, state graph. That's why we just use it by,
Oh, my examples?
It was, yeah, you send me a request.
Oh, okay, but for goodness sake, that's just a particular application. That's not the point.
Exactly. Yep.
Now, do you have any way of detecting automatically that this layer digraph thing should go symmetrical?
Not at this time.
Okay, second point. Do we have a gallery in the documentation for if I look at graph layout, do we have a gallery here?
We just have in the data where we have a review.
That's not bad. That's not bad at all.
I mean, yeah, we built the picker tables basically.
It's not terrible. The fact that I haven't looked at this is a bad sign. So I think it's hard for me to understand what. Well, I mean, I can't really complain about this. That does seem reasonable. I didn't even know we had linear embedding. I should have used that. I mean, I used that years ago. I made my own version of that. When did we introduce that? Don't tell me, a decade ago.
I mean, we have many.
Yeah, I think since the first version, I think.
Discrete spiral is another one. I mean, okay, linear meaning on a line. Yes. Okay.
I mean, they were all in graph plot, right?
Oh, you were calling it symmetric layered embedding. Great. Which is what that's just a rename of this. Okay, rotation option to all of these. So how does that work?
So it's a kind of a sub-method option of graph layout.
Yeah, not my favorite way of constructing these things. I don't quite understand why. I mean, I would have expected the rotation to be a rigid rotation. Why?
Yes, it's a bug, actually. We find out that it should be. We forget to add the center, the computation of the center. So we fix that today.
I see, okay.
It's a rigid rotation.
Okay, well, I love this symmetric layered embedding because I'll certainly use it. All right. I don't think we should look at this this second.
It's not ready. So I got to run.
Okay.
Anything?
No, I think this was you know.
I'm amazed that we got through it. That's great.
Yep. Okay. Thanks a lot, guys. Oh, Sander says on a live stream that he has ideas for tests. So
great.
Great.
We love to hear about them, Sander.
Okay. See you all soon.
See you.
Bye.
Bye.